everyone, my class 9th ninjas, my dear champions, my wonderful kids. So my dear all class 9 champions, I have come up with one short video of Ganit Manjari chapter number 5. I am up and down and round, which is very interesting chapter. And round means we are going to talk about circle, circular shape, circular body, and so many more things. Okay, so this video is going to be entirely one short video, and I'm going to teach you from basics to advanced complete. Everything will be cleared here. So let's move. Okay, so let's have a glimpse what exactly we are going to talk about here in this chapter. I mean, short overview. So what this chapter covers: circle and its parts. What is circle? The basic information of circle, introduction, and the parts of the circle, like radius, diameter, chord, and arc. Second, circle throw points. How many circles we can draw? Throw a single point, throw 2 points, throw 3 points, non-collinear points. Third, perpendicular from center. So few theorems are there, few rules are there. So we will be discussing about all the theorems. These are the theorems, cyclic, quadrilateral. So this is the entire chapter of circle. Basically, I am up and down and round. Moving ahead. Okay, so let's start the class. Okay, so my dear, the first aid, what is circle? Define circle. Everyone know where is radius, where is diameter, how to find a chord, what are the theorems, what is cyclic, quadrilateral. But you know, if I ask someone define circle, they get stuck. Yeah, I found this problem. You guys know everything about circle, but you are not able to define the circle itself. So what is the definition of circle? Let me give you the definition. So basically, the definition given here, by the way, and the definition is the locus. What is called locus? This is the new word for you. Don't worry, I am here. The locus of all points in a plane that are at a fixed distance, and that fixed distance is called radius, from a fixed point, and this fixed point is called center. This is center. And what is mean by locus? So let me tell you locus. So basically, there are so many points in such a way, on a plane. This is a plane basically. For example, if I talk about, this is a mobile phone, right? So a screen of this mobile phone is plane. So if I'm taking so many points on this screen in such a way, in round shape, and if we connect all the points, this connection is called locus. This connection is called locus. But there is a condition. The locus of all the points in a plane is such that the distance from a fixed point, this is a fixed point, the distance from a fixed point should be equal in every direction. The locus of all points in a plane that are at a fixed distance. So distance here in this, first make the locus. So this will be the locus. And the distance from a fixed point, let's say this is a fixed point. From a fixed point, these distances will be equal to each other. If all the distances in every directions are equal to each other, then this locus, the blue color part, this blue color boundary is called circle. And this fixed point, the point here, this fixed point is called center. This point is called what, champion? Center. And this fixed distances, white color pattern, all are radius. And this blue color portion, this blue color is locus. Locus of all the points. How many points were there? So many points were there. And the locus in such a way that the distances from this fixed point is equal in every direction. And this locus is called basically circle. This is circle. I hope the definition of circle is clear. The locus of all points in a plane that are at a fixed distance. Just imagine, I have a locus here, this form, and this is the fixed point. If we draw a line here and here, is this both distance are equal to each other, R1 and R2? No. R1 and R2 are not equal to each other. So that's why this is not a circle. But if it would be look like this, the distance in every direction from this fixed point is equal, R, then this locus will become radius, a circle. So for circle, the condition is that the distance from the fixed point in every direction should be equal, right? So this is the circle basically. This is circle here. This is circle here, and how many points were there on boundary? So many points. And the yellow color boundary is locus. These are the points, and all the points, the white dots are on a plane. Okay, and let me show you the fixed point. The blue color point is the fixed point, which is basically center. And let me show you the white green color. These all are radius. If we draw distance of blue dot from the boundary, all the distance are equal to each other. All are equal to each other. All are equal to each other. So this yellow color portion is called circle. This green color is called center, and these lines, these patterns are called radius. The fixed distance is called radius, the fixed point is called center, and the complete locus, the boundary, is called circle. Clear, everyone? Okay. Okay. I hope this is clear to you. Okay. Now one more thing, champions. I hope this is clear to you all. So the important part is, in a circle, this is a circle here. Let me give you a short more information. Let's say we have circle here. There are three possibilities for a point which is relating to the circle. The first possibility, a point can be exterior of circle. Let's say point A. This point A may lie on the circle, or this point can be inside the circle. So there are three possibilities for a point. A point can outside the circle, a point can on the circle, this is, and a point can be inside the circles. There are three possibilities: exterior, interior, on. Exterior, interior, on. So whenever if I say there are 3 points on the circle, then you have to mark the 3 points on the circle. It means on the boundary. If I ask you to mark a point inside the circle, so the point will be inside. If I ask you to mark a point P outside the circle, so point will be outside the circle. I hope this is clear to you all. Okay. Okay. So this is all about. Clear, everyone? Now let's talk about here diameter. What is called diameter? So basically we have this circle, and here will be center. I will be giving you information about if the center is unknown to you. If you don't know the center, where is the center? We can identify center also. There is a few geometrical approach is there. So by following that, we can identify the center of the circle if the center is unknown to you, if you don't know the center. Okay. So basically this is the center, and there are 2 points here, P and Q, and both the points are on the circle. So if 2 points are there on the circle, and when you join P and Q, this line is called chord. This is called, champion, what is called? Chord. C-H-O-R-D. So what is the definition of chord? The line joining of 2 points kept on the circle, on the boundary of the circle, is called chord. First chord, second chord, third chord, fourth chord, fifth chord, sixth chord. Oh my God, this chord is passing through the center. 7 chord, 8 chord, 9 chord, 10 chord, 11, 12, 13, 14, 15, 16, 15. How many chords we can draw in a circle? Infinite chords can be drawn inside the circle. Infinite chords, please note it down. Infinite chords can be drawn in a circle, but there is very special information there. Can you see the special information? The longest chord is passing through the center. If you can observe, if you guys are able to observe, please observe there. This is the chord. The length of the chord is increasing, and this is the longest chord. And now if you move ahead, if you move up, the length of the chord is now decreasing. First increasing, now decreasing. So it indicates that this chord will be the longest chord. This chord will be the longest chord, and the longest chord of the circle is called diameter. So the definition of diameter is clear. The longest chord of the circle is called diameter, or the line passing through the center of the circle is called diameter. But the line should not be outside. The line should be inside the circle. So better to write the definition will be, this will be the perfect definition. The longest chord of the circle is called diameter. And do you know, very interesting thing, champion. So if this is center, this will be radius, this will be radius. So radius plus radius is equal to diameter. So diameter is the double of radius, 2r. Diameter is the double of radius. And diameter is what? Diameter is the longest chord. Right, everyone, clear? So we have one question here. The diameter of a circle is 3.8 centimeter. Find its radius. What will be the radius? If diameter is already given to you, so the radius will be d by 2. And diameter we have 3.8. So we can put here 3.8 divided by 2. So this will be 1.9 centimeter. The half of 3.2 is equal to 1.9 centimeter. Right? Also state the longest chord of the circle. We know the longest chord of the circle is basically diameter. So this is chord here, this is radius. So I hope this is clear to you, everyone. Moving ahead. Okay, now let's talk about theorem number 1 according to Ganit Manjari. Okay, so the theorem number 1 is circles through given points. How many circles we can draw from 1 point, from 2 points, from 3 points? This is the theory that you need to understand. Please understand, everyone. So how many circles we can draw through 1 point? So listen, champion, please focus. If we have 1 point here, the white dot, and if I ask you how many circles can be drawn, that should be passing through this particular point. How many circles we can draw? How many circles? Let me show you. First circle, second circle, third circle, fourth circle, fifth circle, sixth circle, seventh circle, eighth circle, ninth circle. All the circles are passing through this point. Oh my God. It indicates that from a single point, from 1 point, infinite many circles can be drawn. Please keep it in mind. Infinite many circles can be drawn. So how many circles we can draw? Infinite many circles can be drawn from one single point. I hope this is clear to you all. Infinite many circles can be drawn from one single point. All the circles will be passing through this red dot. Now moving ahead, through 2 points. How many circles we can draw from 2 points? Okay, let's check it once. So we have 2 points here, champion. This is very interesting. I need some space here, so I have to erase this portion. Okay. So we have 2 points. 1 and 2. Let's say A and this is B. If I ask you how many circles we can draw such a way the circles should pass through these points, how many circles? So let's check it once. So my dear champions, the first circle we can draw like this. Right? Second circle we can draw like this. Third circle we can draw like this. Fourth circle we can draw like this. So many circles we can draw. But the interesting point here will be, let's join these 2 points. And let's draw the perpendicular through this point. And here, perpendicular through this point. So this is the line joining. My dear champion, if we mark so many points on this dotted line, how many points we can mark? We can mark so many points. If so many points, it means that so many circles. And all the circles will be passing through these 2 points. Yes, I'm giving you this clarity by taking 2 circles only. So I have drawn 2 circles and both the circles passing through AB. And the line joining AB is perpendicular. And if this line joining, the center C1, let's say I'm taking this as C1, center C1 and center C2. The line joining center C1 and C2, we have a straight line. And how many points we can mark on that straight line C1 and C2? So many points. So these points will also be the center of any circle. And that will be passing through AB. Yes, champions. I hope this is clear to you all. So in this case also, how many circles we can draw? Let me show you. I'm drawing a bigger circle. Look, this is the circle. I'm drawing one more circle. This. So many circles we can draw. And the center of all the circles will be lying on this line itself. This line itself. All the centers will be lying on this line. So how many circles we can draw? This will be the center of any circle. 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 This will be the center of any circle which is passing through A and B. So how many circles we can draw? Again, infinite many circles. Yes, champions. Infinite many circles we can draw, which will be passing through 2 points A and B. I hope this is clear to you all, because the center of all the circles is lying on this line. Okay, moving ahead. Now from 3 points. So these 3 points are non-collinear. Please make sure to mention there. Oh my God, by mistake it has erased. So from 1 point, how many circles? This is the common point. Infinite circles. Clear, everyone? Infinite circles we can draw. From 2 points, first, this is the circle. This is the circle. This is the circle. This will be the circle. Okay, and the line joining this. And if you draw a perpendicular line to this, so many points can lie on this. So it indicates that so many centers. The points are A and B, let's say. Okay, all the circles are passing through A and B. So here also infinite circles. We can draw how many circles? Infinite circles. Okay, now third. So 3 points, and all the 3 points are non-collinear. And it has to be non-collinear because we are talking about circle. Okay, so points can't be in straight line. So this is non-collinear. Okay, so we have 3 non-collinear points. So let's say A, B, and C here. A, B, C here. How many circles we can draw? That will be passing through all these 3 points. Only one circle is possible. Yes, my dear champion, because when you draw line here, the perpendicular bisector of AB will be somewhere, and the perpendicular bisector of BC will be somewhere here. And this point will be the center of the circle which is under making. This will be the center. And such center is possible, only one center is possible, because we have 2 sides AB and BC which will be working as a chord of that circle. And if we draw the perpendicular bisector of AB and BC, both the perpendicular bisectors will be meeting at only one point. If only one point, it means only one center. If only one center, it means only one circle. So let me draw the circle. Now you can keep the compass tip, iron needle at this point, and pencil at this point. You can draw the circle. So only one circle will be there. Let me draw the circle. This will be the circle. And look, I can't draw the perfect circle here because I'm teaching on board, so it is little slippery, so I can't draw the perfect circle. So this will be the center somewhere. So only one circle is possible. Only how many circles? One circle. Only one circle is possible. Clear, everyone? So from one single point, infinite circle. From 2 points, infinite circle again. But from 3 points, from 3 non-collinear, only one circle is possible. Moving ahead. So theorem number 2, it was theorem number 1. Let's talk about theorem number 2. Perpendicular from center to a chord. So my dear, this is very interesting theorem. This theorem says that the perpendicular from the center to a chord bisects the chord. Let's say we have circle here, and we have a chord here. This is A and this is B. AB is a chord. Theorem says that if you draw the perpendicular from the center to the chord, let's say this is chord here, AB is chord. This AB is what? Chord. And here we are drawing perpendicular from the center. So theorem says that if you draw perpendicular from center, the chords divides into two equal parts. Yes, my dear. So here AP will be equal to what? PB. This is the theorem. The perpendicular drawn from the center to a chord divides the chord into two equal parts. So AP will be equal to AB. And that's why this is called perpendicular bisector. The line drawn from the center to a chord is called perpendicular bisector. Now we can say this is working as what? Perpendicular. Why perpendicular? Because 90 degree. And we are mentioning here the word bisector. Why bisector? Because the chord is getting divided into two equal parts. AB was the complete chord, but here AP will be equal to PB. This is the theorem. Now we have question here. Look at the question. AD is the diameter, so this is circle. AD is the diameter, okay. AD is the diameter of a circle and AB is a chord. Okay. The question here is, I have a circle, okay, and AD is a diameter, okay. So AD will pass, this is A and this is D, and it will be passing through center because AD is a diameter, and then diameter always passing through center of a circle, and AB is a chord. If AD is equal to 34 centimeter, here AB is equal to 34 centimeter, and AB is equal to, this is AB here, and this is equal to 30 centimeter. Find the distance of chord AB from the center. Very good. So we have to find the distance of AB from the center. So this is center here. So we have to find this distance. And if we draw the line from center, oh my God, this will be perpendicular according to theorem number this. When you draw line from center to a chord, it is always 90 degree, always 90 degree. So this angle will be 90 degree. And we have to find out this. Let's say I'm mentioning this as O and I'm calling this as M. So we have to find out here OM. What will be OM? My dear champion, if this is 90 degree, so we have AOM, AMO, right angle triangle. So in right angled, 190 degrees is enough to call a triangle as right angle triangle. In a right angle triangle, and the triangle name is AMO. Triangle name is AMO. In triangle AMO, and this is 90 degree, here is 90 degree, so this will be hypotenuse. So AM square plus OM square plus OM square, that will be equal to AO square, because AO is the hypotenuse. Can you see? Here is 90 degree, this is 90 degree, so this will be hypotenuse. So AM is what? Where is AM? AM will be half according to theorem number 1. AP is half BB, so the entire AB is 30, so half will be 15. So we can put here 15 whole square, and we have to calculate OM, which is the distance of chord from the center, and AO, this AO is the radius. Entire diameter was 34, so the radius has to be 17 square. So here OM square will be equal to 17 square is equal to 289 minus 15 square is 225. So that will go right side, so it will be in subtraction. So OM square, can we please subtract this? So this is 4 and this is 8. Oh sorry, 6. 8 minus 2 is 6. Okay, just a second. So this is 6. Wow. I hope this is clear to you. So OM will be what? After removing a square, 64 will go in root. So OM is equal to 8 centimeter. This is the question here. Clear everyone? This is the question. This is the question. OM is equal to, so just applying Pythagoras theorem. Why I have applied Pythagoras? Because if this is 90, so it has to be 90. So this triangle, let me highlight the triangle. This triangle, this this and this. Here is 90 degree. Okay, so this triangle is 90 degree, and if you mark an arrow from 90 degree, that side is hypotenuse. Right, everyone? So this is the solution. I hope theorem is clear. Clear, everyone? Okay. So, so the here is theorem number. Basically, we have solved the question here. Actually, the theorem number 3 is here. Chords and distance from the center. Very easy theorem. So look at the theorem. Let's discuss about theorem. Equal chords are equidistant from the center, and longer chord lies near to the center. Okay. I hope you guys, your English is little good, so you guys can understand the language given there. Equal chords are equidistant from center. Listen, champion. Just imagine we have a circle here, and O is the center, and I have two chords here. Let me hide this M first. This M is nothing is here. Okay, so I have two chords AB, and let's say I have one more chord PQ. This is called PQ, and both are, just imagine, suppose AB is equal to 4 centimeter and PQ is also 4 centimeter. So this theorem says that equal chords are also at equal distances from the center. So if we draw this distance of chord AB, for example, just imagine this is X centimeter. So the distance of this chord from the center will also be, and we know it has to be 90 degree because this is the theorem. The line drawn from center to chord is equal to 90 degree. So this will be 90 degree and this will also be X centimeter. So this theorem says that equal chords are always at equal distances from the center, X centimeter and X centimeter. I hope this is clear to you all. Okay, equal chords are at equal distance from the center, and do you know, my dear champion, just imagine if the chord is here, I have one chord here and I have one chord here. In both the chords, blue color part I'm asking about, blue colors, both the blue color chords. In both the chords, this blue color, which is longer? This one is longer, and this chord is close to center. Look, this is close to center, and this is very far away from the center. So the chord which is longer in size, is always close to the center, and the smaller chord is away from the center. This is the longer chord lies nearer to the center, and the smaller chords are away from the center. And equal chords are always at equal distances from the center. I hope this theorem is clear to you all. For example, I have the circle and these are two chords. This chord is of 6 centimeter and this chord is of 4 centimeter chord, and the center is here. Now can you imagine, can you see here, can you observe, this 6 centimeter chord is very close to center, and this 4 centimeter close is away from the center. So this is the theorem. Basically, the longer this is the center. Okay, the longer chord is close to the center and the smaller chord is away from the center. This is the theorem. And if both the chords are equal, for example, this is also 6 centimeter. Oh my God! So equal chord. So this distance is equal to this distance now, because both the chords are equal. So the theorem says that equal chords are always at the equal distance from the center. Moving, theorem number 4. Okay. Now the theorem number 4 is equal chords of a circle sustain equal angle at the center of the chord, which is very interesting. Look, I have this circle. Oh my God! What a circle! What a circle! Can anyone place this picture of this smartboard in a museum of Delhi, National Science Museum? Look at the circle. Oh, sometime the teacher should also feel proud on themselves. No, the way I have drawn the circle without any equipment. Wow, what is this, guys? Put in comment. Okay, so this is circle here. What is theorem? Equal chords. So let's make a 2 equal chords. I have one chord here, and I'm taking one more chord here. And both the chords are equal in length, right? So equal, let's say this is A, B, and this chord is PQ, right? And center will lie somewhere here. This will the center O. Okay. Equal chords of a circle subtend equal angles at the center of the circle. So this theorem says that if two chords are equal in length, so they always subtend equal angle. For example, if I join A and B from point O, which is center, this angle, and if we join P and Q from the center, this angle, both the angles are equal to each other. So equal chords subtends equal angle at the center. This is the theorem. For example, if this is 60 degree, right, so it has to be 60 degree because both the chords are similar. So we can prove it also. If the question comes like prove that equal chords form equal angle at the center. How to prove? Listen, champion, we can prove it. So we have two triangles. We can prove it. So in triangle, the triangle name is AOB. In triangle AOB and triangle, this is POQ, or we can also write QOP. So this is POQ, right? So we have two triangles. In both the triangles, the first is AB. AB is equal to PQ, which is given to you because both the chords are equal to each other. Agree everyone? AB is equal to PQ. Now, this AO is the radius. So AO will be equal to PO because AO and PO both are radius. And this is also radius. OQ and this BO both are radius. We can write here radii of the circle. Right. And one more thing we have here is OB will be equal to OQ. Again, a radii of the circle. So side, side, side. So by triple S congruency, triangle AOB has become congruent to triangle POQ. And now, my dear champion, if both the triangles are congruent to each other, we have proved it mathematically, both the triangles are congruent to each other. It means this triangle POQ is overlapping to the triangle AOB. Just take this P and Q point and flip this triangle this side. Flip this triangle this side. So this whole triangle will be overlapping to that. And it implies this angle will have to equal to this angle. So hence we can write here, hence angle AOB is equal to angle POQ by CPCT, corresponding part of congruent triangle. Clear everyone? So this is the proof. Equal chords subtend this angle will be equal to this angle. Moving ahead, theorem number 5. Angle at the center versus angle at the circumference. Very important, very interesting. And we have one question based on this theorem. This is the question we have to solve. So the theorem says that angle subtended by an arc at the center, okay, is twice angle subtended at the circumference. Okay, let me tell you. Let me explain this theorem for you. We have this circle and the center is at this. This is the center. This is the center. So the theorem says that the angle subtended by an arc at the center. So this is the arc. This is called an arc. This arc. And this arc is making an angle, red color of this angle, theta. For example, this is theta at the center. My dear champion, this red color arc is forming angle theta at the center. Now, except red color, without red color, this will be the remaining part. Can you see? This will be the remaining part. Come on, leave the red color. Apart from red color, this will be the remaining part. So the theorem says that if an arc is making some angle at theta and taking these 2 points again, but the angle is in white color portion, anywhere, here. But taking these 2 points again, A and B will be considering there, but the angle is in circumference, in white color portion. So that angle is always half of this. Or we can say, if I'm taking this as theta, so it has to be what? 2 theta. So the angle at the center is twice. The angle, this will be, oh my god, white color, I need white color. So, yeah, this will be 2 theta. I hope this is clear to you all. You can take any angle, anywhere. This, again, this will be, if this is 2 theta, it has to be theta. You can take anywhere in white color portion. This will be what? Theta. You can take anywhere. But these 2 points will be participating, theta. My dear, I hope this is clear to you all. So if an arc is making some angle at center, the angle at the center is always twice to the angle which is forming in the remaining part except red color. That angle will be always half. Clear everyone? So if, just imagine, I have a triangle here. I have triangle. And this is the angle, this is the center O. And there is an angle, and this angle is basically making by this arc. So if I'm taking a part here, this part, can you see? Again taking these 2 points. So if this is 30 degree, so what will be this angle? This will be 60 degree. Angle at the center is twice of the angle, angle at the center is twice of the angle which is making in the remaining part except this arc, leaving that arc. So center angle is always twice. Look at the question, chord AB. So let's draw the diagram here. So we have a chord. This is chord AB. Okay, chord AB is sustained an angle of 60 degree at the center. Perfect. So if a chord is making angle 60 degree at center, oh my god, if this chord is making 60 degree, it implies also that the arc is also making. If chord is making 60 degree, it means arc is also making 60 degree. Okay. Find the angle sustained by AB at a point C on the major arc. So this is called, the smaller arc is called major arc, a minor arc. My dear champion, basically this small arc, this is called minor arc, and the remaining part except this red color is called major arc. So the angle forming at the center due to minor arc is always twice of the angle which is forming in major arc. This is the theorem. So if this is 60 degree and I am taking here, the question is find the angle sustained by AB at point C in the major arc. So let's say this is, because this will be major arc, this is the major arc, and here we have this is what? Minor arc. So my dear, according to theorem, if this is 60 degree, it has to be what? 30 degree. Answer is 30 degree. Clear everyone? So this is the theory. The angle in the major arc is half of the angle of the minor arc, and minor arc means smaller arc, major arc means the bigger arc. Moving ahead. Okay, theorem number 6, angle in semicircle. So my dear champion, you know semicircle? The half of circle is called semicircle. The half of circle, and a diameter sustained a right angle. Let me give you an information. Listen, go to the previous theorem. What was the theorem? The angle sustained at the center due to minor arc is twice of the angle forming in the major arc. Just imagine. Let me give you a very magical information. I have a circle, and this is chord, and here is some angle. If this is theta, so what will be this, champion? What will be this? Theta by 2. Again, if I have angle X, so what will be this angle, champion? x by 2 half, because this is the center. So this is minor arc and this is major arc. Again, I am continuously increasing this angle. Look, now this is angle and here is center. Okay. So what will be this angle? For example, if this is y, so what will be this, class 9th? Y by 2. The angle in minor arc is always twice of the major arc. So if the angle in the minor arc is y, so major arc will be y by 2. Okay. Now if I'm again increasing the angle, and this is the center, and this angle, can you see? I was gradually increasing this angle. First this angle, now little more broader, and now this is completely straight line. And if this is completely straight line, my dear champion, this is equal to 180 degree. And completely straight line means what? Now this line is become what, champion? Diameter. Yes, my dear champion, this is 180 degree. And if you draw a line, angle in major arc, I mean the remaining half part of the circle, so 180 half, this is equal to 90 degree, and this is called angle in semicircle. So basically this theorem, angle in semicircle, is little related to this, because if we talk about here, this angle AOB is a straight line. AOB is a what? Straight line. And if AOB is a straight line, so angle AOB will be what? If I ask you angle AOB has to be 180 degree, because this is completely a straight line. This is 180 degree. Now taking these 2 points, draw an angle in the second half of the circle. This is the first half in which 180 degree is there. This is 180 degree, na? This is 180 degree. This is 180 degree, right? And this is the second half of the circle. So this angle has to be half of 180, and that's why this is 90 degree. Wherever you draw line, wherever you draw, either you draw here, either you draw here, either you draw here, all the angles will be half, means 90 degree. And this is called angle in semicircle, because AOB is a straight line. It means AOB is a diameter. So this circle, the upper part is half and the lower part is half. And half circle is called semicircle, and that's why the theorem is angle in semicircle. Clear, everyone? So a diameter subtend a right angle at any point on the circle, right, everyone? So okay, so we have question here. Let's solve the question here. AB is a diameter. Okay, so A and B is a diameter, so somewhere here will be the center. O. AB is the diameter of a circle, and C is the point on the circle. Okay, C is the point on the circle. Angle CAB, perfect. So we have C here. Let's say this is C, and angle CAB. Okay. Now join this also. CAB, and this angle is equal to what? 35 degree. Okay. Find CBA. Okay, we have to find this. For example, this is X. What will be this angle? If AB is a diameter, so this angle has to be 90 degree according to this theorem, because this angle is in semicircle, because AB is diameter. So we have a triangle ABC, and in any triangle we know the sum of all the angles is equal to 180 degree. So X plus 35 plus 90 is equal to 180 degree according to angle sum property. Now X will be equal to 180 minus 90 plus 35 will be 125. Okay, so X will be equal to 5 and 7. This is 55 degree. Answer. X will be 55. So angle CBA is equal to 55 degree. This is the answer. Angle CBA is equal to 55 degree. Clear, everyone? Either you take angle in this part or in this part. Both are semicircular part, no? So angle in semicircle will always be 90 degree. Theorem number 7. Angle in the same segment. This is interesting. What is called same segment? First understand this. So angles in the same segment of a circles are always equal. Same segment, listen champion. So we have circle here. Look at the circle, and AB is a diameter. My dear champion, considering AB considering AB, if we draw an angle here, this angle, can you see angle ACB, and again considering A and B, one more angle ADB. We have one more angle ADB, but the interesting part is both the angles is lying on this part. Both the angles, let me use white color, both the angles is lying in this part of the circle, the white color of the circle, and this is called same segment. You take here angle, you take here angle, you take here angle, you take here angle, all the angles will be equal to each other. Why? No angle is in this part, every angle is lying on this part, and this is called same segment. This is called same segment, right everyone? So this angle will be equal to this angle, 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 this angle, this angle, all the angle. We can take here also, again this angle will be also. Why? Because all the angles are forming in that part. If we draw an angle here, this, or one more angle, now these two angles will be equal to each other. Why? Because these two angles is lying in this part of the circle. Both the angles should be either upper portion to the chord, or either both the angles or 3-4 angles should be lying in the down part of the chord. Clear everyone? So this is important. So angle in the same segment of a circle are equal to each other. For example, one more thing. So I am drawing here this angle, and the angle is starting from A and is ending at C. So A and C are the 2 points, terminal points, which is making angle. Again taking A and C, if we draw angle here like this, now the chord will be here, and both the angles are lying on the same segment, upper part of the chord. So if this is X, it has to be X. Clear everyone? So this is called angle in same segment. So let's do a question for your clarity. Point C and D lies on the major arc of a circle. Okay, so we have circle here, and major arc of a circle on the same side of a chord. Very good. So we have this chord AB, because this is here information, and C and D, 2 points are there. C and D lies on the major arc. So let's say this is C and this is D, because this will be minor arc, this will be major arc. I hope this is clear to you all. This arc is what? Major arc, and it has to be what? A smaller part is minor arc. Here the points are, both the points C and D lies on the major arc. So this will be the point. Now, if angle ACB, this angle is equal to, if this angle is equal to 45 degree, find ADB. Oh my God, what will be ADB? Same angle, la? Because both the angles are lying in the same segment. Okay, so angle. Now how to write the answer? Listen, champion. So here we can write angle ABD will be equal to angle what? ACD, and please mention the region by, or we can directly write angle in angle in same segment. Both the angles are in same segment, so ADB has to be, ABD will be also equal to ACD, which is 45 degree. So ABD is also 45 degree. This is the answer. Clear everyone? So angle in same segment. Moving ahead, so let's talk about cyclic quadrilateral, which is the most lovable chapter for the teachers, and you will be getting one questions definitely from this particular theory. Okay, so cyclic quadrilateral means what? There is a cycle, there is a circle, and there is a quadrilateral. So a quadrilateral inside a circle, this is called cyclic quadrilateral. So in a cyclic quadrilateral, let me show you. The definition is clear everyone. When a quadrilateral, whether it is square, rectangle, parallelogram, trapezium, anything, a quadrilateral is lying inside a circle. Okay. So, my dear champion, in a cyclic quadrilateral, each pair of opposite angles adds up to 180 degree. Yes, this is the beauty of cyclic quadrilateral. I have a circle here, and can you see ABCD? This ABCD is what? Quadrilateral. ABCD is a quadrilateral, right? This is what? Circle. So this entire diagram is cyclic quadrilateral, right? Okay, so the beauty of cyclic quadrilateral is the sum of opposite angle A and C. The sum of opposite angle A plus angle C is equal to 180 degree. This is the theory. And sum of angle D plus angle B plus angle D is also 180 degree. This is the theory. This is the essence of cyclic quadrilateral. For example, if this is 120 degree, it has to be 60 degree. If this is 110 degree, it has to be 70 degree. The sum of these two should be 180 degree. The sum of these two should be 180 degree. Diagonally opposite angles. Right, everyone? Let's do a question here. ABCD is cyclic quadrilateral. Perfect. So circle is there. And let's say A, B, C and T. ABCD is cyclic quadrilateral in which A is 80 degree. Perfect. This is given to you 80 degree. B is 70 degree. Very good. 70 degree. Find C and D. Very good. Very good. Very good. So my dear champion, the sum of opposite angle will be 180. So we can put angle A plus angle C is equal to 180, and we can write the region here. What? Cyclic quadrilateral. Or we can also write opposite angle of cyclic quadrilateral. Lateral. Okay. So A is equal to 80 plus C is equal to 180. So 80 will go there, will become negative. So angle A is equal to 100 degree. Right. Similarly, this is B and this is D. So angle B plus angle D is equal to 180 degree. Again, the region will remain same, cyclic quadrilateral. So the sum of opposite angles will be 180. So B is 70 and plus D we don't know. So angle D is equal to 70 will go there. So 180 minus 70 will be equal to 110 degree. I hope this is clear to you. Very easy question. So this is all about your chapter number. I am up and down and round and round. So final glimpse, formula and theorem we have discussed. Radius is equal to twice, diameter is equal to twice of radius. The length of diameter is basically twice of radius. So D is equal to 2R first. Theorem, exactly one circle passes through three non-collinear points. So if 3 points are like this non-collinear, so only one circle is possible. Perpendicular from center bisects the chord. If there is a circle, center, and this is a chord, if you draw a line perpendicular from center, it divides the chords into two equal parts. Longer chord, this is very simple. If there is a circle, longer chord will be close to the circle and the smaller chord will be away from the center. So you can see this is closer to the circle and this is the away from the circle. Okay, angle subtended, angle at center. We have studied here angle by the minor arc and taking these two same points, angle at the major arc. So if this is theta, it has to be 2 theta. So this is the theorem. Angle at the center is twice angle at the circumference. Angle in semicircle is always 90 degrees. So this is a diameter and here is center O and this is B. So AB is a diameter, and if you draw line here semicircle, this angle will always be 90 degree. So angle in semicircle is always 90 degree. Angle in the same segment are equal. So we have this angle, and on taking these two same points, this angle, both the angles will be equal to each other, x and x, because this will be the chord. So angle in same segment. Cyclic quadrilateral, I have already taught you here. If we have a cyclic quadrilateral champion, the sum of this angle x plus y is equal to 180 degree, and the sum of this angle A and B, so x plus y is equal to 180 degree and A plus B is equal to 180 degree. This is the property of cyclic quadrilateral. The sum of opposite angles are equal to 180 degree. So thank you so much for watching this video. I hope this video will really help you out. So this was the chapter explanation, theory, concepts. In next video, I will be coming out with the next video very soon, and in that video I will be solving NCERT questions as well as some extra quality questions. Thank you so much for watching class 9th Ninjas. Take care of yourself, take care of your parents. Bye bye everyone.